Hello everyone, this is FixRev, and today we have an XR30 Gen3 Radion light that we fixed previously. It's working just fine, but today we are going to upgrade it to XR30 Pro. As you can see, in the XR30 version, there are two LEDs missing from each of the LED modules. There is a yellow LED right in the center, and there is a deep blue LED in addition to the other ones that they have around the pack over to the left. And the same situation here. There is one in the center that is yellow, and that's the one on the left that is deep blue. And that is really the only difference between the two versions. The Pro version just has additional 4 LEDs in it. No more channels, same 6 number of channels. I believe that the yellow LED is managed by the white channel, and the deep blue LED is managed by the deep blue LED is managed by the royal blue channel, whatever they call it. So let's get to it. First of all, let's take a look at the layout of the LEDs. Once again, in this layout, the XR30 Gen3 Non-Pro has 2 LEDs missing. The yellow one, right in the middle here, and the deep blue one, 6 on XR30 Gen3 and 8 on the Pro version. So all we need to do is just add these 2 LEDs to each puck, and we are going to have a Pro version of this. The big question comes whether or not the Radion is going to recognize the new LED modules and switch itself to Pro version once those LEDs are added. Today we're going to find out. So as you can see in Ecotech Live, when the light's plugged in, it's recognized currently without the additional LEDs as a non-Pro version XR30 G3, not G3 Pro. You can see that it's got the latest firmware installed just in case it's necessary so that it would recognize the new LED modules. Everything else seems really good. So the question is whether or not this is going to change to Pro once we add additional LEDs to those LED modules. The first thing we're going to do is take the LED modules out of the fixture, disconnect the power, remove the screws, and take the modules out. Then we're going to look under the microscope to get a better idea of what we are dealing with, and I will explain the process as we go. All right, so it is important to disconnect the board from the USB power, even though your main power is disconnected. As long as the USB is connected to your computer, you're going to have the 5 volts off of USB still feeding into the USB controller over on this main board. So it's best to disconnect it so that it's completely powered off. Now everything's disconnected, and we can proceed. LED puck number 1 and LED puck number 2. All right, we won't need the light fixture for a while, so that's going to be removed and put away. Now we're going to clean up the mess of the thermal paste so that we don't leave that on any other surfaces. We don't need any kind of mess around here. Everything is nice and clean. We can always add more thermal paste once we're ready to reassemble the light. But for now, it's all gone from here. Very good. Okay, so let's take a closer look at the missing LEDs from here. So this is D6, which is the deep blue, and D17, which is the yellow. You can see that the yellow is actually controlled. It's connected to the red channel D15, and over here it's connected to the other one. So the yellow is going to be controlled by the red channel. I think I misspoke and I said white previously, but it's actually on the red channel. And the deep blue should be connected to the other deep blues that are already on the board. Well, the first thing we're going to do is we are going to remove the solder that's already on the pads where LEDs are supposed to go in. We will do so because this solder is unleaded. Unleaded will have a higher melting temperature than leaded solder that we use here. If we remove the unleaded solder now, we don't have to heat up the entire module to as high as melting the solder under all the other LEDs, and so we are reducing the stress that other LEDs are going to be subjected to, while still being able to solder new LEDs in place securely and properly. Let's move all of the unleaded solder completely. These LED modules are aluminum based. So they will consume and soak in a lot of heat. So we have to use a bigger soldering tip and a higher temperature to make sure that we get proper temperature to melt everything. Okay, so now we have the unleaded solder removed. We're going to clean it up before we apply leaded solder on it. Nice and clean. Very good. So now we're going to apply leaded solder to all of the pads. And it's probably a good idea to add a little bit of more flux here for so that we have easier time applying the solder. Okay. Make sure that there are no bridges and apply just enough of this. Don't need a whole lot. Okay, so we got enough solder applied, and the excess solder is going to be removed later. We will take care of that later. All right, so the solder is now applied, and we are ready to place LEDs there. And we will do the same for the other module as well. Apply some solder, apply some flux, remove unleaded solder. Apply some more flux. Add leaded solder. And that looks good. Remember to clean up as much flux as possible. It comes off real easy on a nice flat surface. And this module is also now ready for new LEDs. All right, let's get some new LEDs. Okay, so we'll need a couple of deep blue ones. Deep blue, and we will need a couple of yellow ones. Yellow, yellow. Before we can place these new LEDs onto the board, we always need to verify the polarity, because for LEDs being diodes, polarity matters. So to do so, what I like to do is just take the LED. You can probably find out the polarity as well looking at the datasheet. But what I like to do is to just use my multimeter in diode mode and just apply a low voltage to them. And whenever it lights up, it means that I got the polarity. No light, light. I don't know how much you can see here, but there is a blue light there. So the one with the notch over here, the one by the notch, is the negative, and the opposite of the notch is the positive contact. So we have the deep blue ones figured out. Let's do the same with the yellow ones. I would imagine that it's probably the same deal, but I just want to verify. So the one by the notch should be negative. The one opposite of the notch should be positive. And it's not. This time around, the notch means positive. You can kind of see that it's lighting up barely. and the opposite from the notch is negative. Okay, that's good to know. So when we look on the board, the polarity is also marked. So this is your positive, this is your negative. So since we said that the yellow has the positive where the notch is, so that by D17 we can position it in such a way that the positive where the notch is over on this side. So it should go like this. And that's how it's supposed to be. And the deep blue is the opposite. Where the notch is the negative. And we got it just right. We will do the same with the other module, and then it will be the baking time. Okay, once again. Positive. And negative. Very good. So now we should be ready to bake. I do not have a camera over my reflow machine, so I'll be back with hopefully both of these completed. And we are back. The modules are back from the reflow oven. You can see that there are solder blobs sticking out of some of the LEDs. So we're going to have to remove those blobs. We don't need them yet. And then we'll just clean up. Okay, a little bit more a little bit more flux. Let's see if we can remove the blobs. All right, much better. And the other one, probably same, likely same problem, indeed. So a little bit more flux. That's not a big deal. It's not going to affect anything because those solder blobs are not really shorting anything. I just, for more of an aesthetic purposes, trying to get rid of them, or at least some of it anyway. Very good. Now all we have to do is just clean up. Notice that there is no damage to the LEDs themselves as we reflow them carefully on specialized equipment. That way, you know that they're not being exposed to too much heat, and they will actually last long. I also wanted to point out that the 0-ohm resistors here are essentially no longer necessary. And they will have to be removed. And the reason they're no longer necessary is because they are supposed to short the two traces when the LED is not in place. But when the LED is in place, these are going to cause a short circuit across, and they will have to be removed. So we'll have to, as we reflow and finalize everything here, we'll need to remove these two resistors. Now that the 0-ohm resistors have been removed, we can finally clean everything up. For both boards and start testing. Everything looks very nice and clean. No problems. LEDs are not damaged. Okay, so one of the things that I like to do before I plug it into the main board is to test individual LEDs to make sure that they light up. Once again, the multimeter in the diode mode, red probe, positive, black probe, negative, and let's test it. For example, one of the known LEDs. This is negative, this is positive, and we have a red light. Once again, negative and positive, green light, negative and positive, blue light. So now we should be able to see the same over here. And our light is, the deep blue is blue. And let's see if we can get the yellow one, and the yellow one is on. Awesome. Now let's test the other board. Once again, blue. This is tougher because the pads are underneath there, but we can use those pads because those are soldered. That's actually easier. And this is yellow on, blue on. Okay, so the both of the LED modules are good. Now we are going to attempt to reassemble and test. Okay, we're dropping the first one in. The second one goes in as well. I'm going to put a couple of these screws through, because now that the thermal paste is completely gone, the heat exchange isn't the best. So we want to, for testing purposes, just for testing purposes, we're going to attach both LED modules as close as we can to the heatsink with the screws, and only run them for at most maybe a minute or so. And then if everything goes well, we will just take them apart, add more thermal paste, reassemble, and we should be in good shape. Okay, so first let's add power and see which LEDs will light up. Here's the moment of truth. Are we going to get a Gen 3 Pro out of Gen 3 by just adding a couple of LEDs? There we go. And we have a working set of LEDs with all of the LEDs on and nothing causing any trouble. The last thing we need to do is we need to make sure that it shows up as a Gen 3 Pro in the firmware. It's not critical, because if LEDs are already on, it doesn't even matter what the Ecotech Life is going to say. It's already a Pro by the functionality that it has. But it'll be nice to see if it's recognized in the Ecotech Life as a Gen 3 Pro as well. So for this, we would need to add our RF module, and we would need to connect the USB. And let's head over to Ecotech Live to see what we get there. All right, we're going to turn on the light. We're going to plug in the USB. It still says Gen 3, not Gen 3 Pro. So the firmware isn't smart enough to recognize that this is a Gen 3 Pro. But nonetheless, it's a Gen 3 Pro. I think the experiment is good. I think it shows that we can easily upgrade to Gen 3 Pro with this by adding the LEDs. Okay, now that we have the LED pucks all working correctly as a Gen 3 Pro, all we have to do is just reassemble. So we're going to add a little bit of thermal paste. Again, very little. I have seen some lights that you guys sent me. There is so much of that paste added by the previous owners that it's sticking out everywhere, complete mess inside. There is no need to have it super thick. This is more than enough. Just barely visible. Just like that. As you're going to assemble this afterwards, it's going to, under the pressure, it's going to flow all over underneath. So it will fill up all of the little crevices around. So this is more than enough of thermal paste. So let's reassemble and see what the final product looks like. So now we're going to carefully attach the main power. We're going to apply fresh Kapton tape. Kapton tape is used here because it's heat resistant. This whole assembly here is a heatsink, aluminum heatsink, so potentially can get real hot. Kapton tape can handle very high heat and not come off, doesn't melt, and so on and so forth. So that's always good. All right, now final touches. And the cover. Now we're going to finally test it off of the main power supply. And it's on. The fan is spinning. All of the LEDs are on. We have a working Gen 3 XR30 Pro as the result of this repair. Well, thanks again for watching. If you like the content, please like and subscribe. And I will see you in the next video.